Our next speaker is a surgeon at the University Hospital in Santiago, Spain, Hospital HM Vigo in Vigo, Spain. His work is multidisciplinary, focusing on minimally invasive surgery, personalized surgery, head and neck surgery, facial deformities, and regenerative medicine. A round of applause for Dr. Pedro Martínez Seijás.
Good morning. I am trying to explain my experience of 18 years in 3D printing. I'm sorry. 3D printing for me is a tool that it's for the patient. And the beginning was several years ago when we saw a CT scan reconstruction. In this way, we think that 3D printing of a biomodel can control variability of the patients and surgeons. In this way, we can avoid bad problems and implement quality control. In this way, it's a team, a multidisciplinary team in which surgeon and bioengineer works together for improve the 3D printing. The levels of 3D printing by the complexity and difficulty is the first level biomodels, second level simulation and tools, and third level custom-made prostheses. In this, there are structural with biomechanics requirements, without biomechanical requirements, and functional requirements. This is my 3D printing evolution since 2001. We began with this case with a specular guide for a reconstruction of hemimandible with custom-made surgical mesh. After, we prevent hardware for surgery, guided surgeries by models, head and neck reconstruction with fibular-free flap, or deformities guided by biomodels. We proposed a multicentric validation study in 2009 for stereotrophic models in mandibular free flap reconstruction. And in 2009, we put the first custom-made prosthesis in Spain. After, we performed custom-made prosthesis by biometrology and optical navigation. Improve new techniques with, this case, a new mid-facial osteotomy. And the second mandibular custom made in Spain for the first for an adult. We improve a new way, a virtual biomodel surgery with engineer that he is very important for our work. You can see why we can work together for improve new processes. In 2015, I present my PhD with this thesis. And in 2016, we present two projects in the hospital that was our. And this is the last cases that was put in a patient in June this year. I am trying to explain some cases that change the life of the patients, like this This a patient that was operated in in several operations. And she has in the head some structures that was PMA polymethyl that we put out and design a new prosthesis for his skill. Another case was this person that has a syndrome with Cruzon syndrome when we perform a new osteotomy guided by biomodels and electronic magnetic navigation with minimal invasive surgery. The first case is for oncologic mandibular reconstruction. In a child, the design, the prosthesis, and the result. The other case of a reconstruction of an oncologic patient was this one that has a hemimandibular reconstruction with titanium prosthesis. And this is the last case that I operated in June with 3D printing mandibular reconstruction. In this patient, the left side of the patient has the mobility with his plate. Here is an animation in which we speak together, the engineer and the medicine. We can speak about what the patient needs and what's the problem that will be occur during the surgery. This case, the mandible was closed, and we put in anatomical position for the reconstruction. And after, the engineer began to design the prosthesis, as you can see. This is the prosthesis that you see before. The surgery control, X-ray control post-operative, CT scan with a good position of the prosthesis, and CT reconstruction for C. What improves C3 printing? Improve variability, technology, surgical navigation that integrating with clinical process management for get personalized surgery. The patients that I have operated this, since 2001, as you can see, and the processes of 3D printing that we perform. This is the people with I work in San Sebastián that work together. My masters, thank you very much. It's a pleasure to tell you my experience. That's it.